Well, good morning or good afternoon, students. We're going to be going over today how to use the mole to help you find the volume of a gas. And let me zoom out here a little bit now. So we've been working with the concept of the mole. The mole allows us to take something that's really small, either the mass of an atom or the numbers of atoms, they're really tiny, and multiply it out, convert it so that we can go measure it in the class with a scale. So that's why I call it the MVP of chemistry. I've given you these before. I call this the roadmap to success for chemistry, because what happens is the mole is a conversion factor that lets us connect grams over here to liters of gas over here to number of particles or atoms over there. So up to this point, we've done practice calculating the molar mass of a compound and converting its number of grams into moles using the molar mass, the grams per mole, or going back and forth. So it's just a matter of either you're multiplying or you're dividing. And it works out whenever you're going towards the middle of this, when you're calculating moles, you're always going to be dividing, whether it's by the molar mass, by the number of particles, or in today's lesson, if you're going from the number of liters to the mole, you're going to be dividing by 22.4. That's one of the magic numbers for gases in chemistry. So what 22.4 is, that's the number of liters that 1 mole of any gas will occupy at standard temperature and pressure. So this box right here, I don't know if you can see that. Maybe I got to extend this some more. Try to get this. Maybe I better put this on the floor so you can see it a little better. So this box right here is about 28 centimeters on a side. Let me zoom out there a little more. Rotate, let's see, this way so you can read it. There we go. So this box is about 28 milliliters, centimeters on a side, and it turns out to be a fairly nice sized cube. Well, it turns out this is going to actually be 22.4 liters inside of here. This volume is 22.4, and any gas at standard temperature, which is 0 degrees Celsius, and at 1 atmosphere pressure, that's how much 1 mole of a gas will take up. So you could say right now we're pretty close to, well, we're a little bit warmer than standard temperature. This box right now is holding about 1 mole of air. And 1 mole of any gas at standard temperature, that's going to be 0 degrees Celsius and 1 atmosphere of pressure. We went over that in the gases unit. It'll be 1 mole. So now getting back to here, let's get this readjusted. So we're back looking at this. So for our practice today, on your paper, we're working now on this top part of the MVP triangle. So our magic number, if we want to use magic to say that term, to convert from a mole to number of liters, we multiply by 22.4 liters. If we're given liters to start with, we're going to divide by 22.4. So on your paper, you've got this, and just as anything, we're going to make the assumptions when we do this that we are at STP, 273 Kelvin, which is also 0 degrees Celsius, and 1 atmosphere pressure. So a lot of these problems will say at STP. You can almost ignore that because it's just the problem we're doing. So here we've got the given, 1 mole of hydrogen. What volume would that be? So that's going to be our given. I'm going to put that over 1, and I'm going to be efficient and just do it like that. So now what we got to do is we got to convert this to how many liters will it be. And according to our MVP triangle right over here, the part of it, we're starting at the middle of this. We're starting at mole, and whenever you're going away from mole on the MVP triangle, you're multiplying, in this case by 22.4 liters divided by 1 mole. So let's get that put in. 22.4 liters of, now this is hydrogen gas we're talking about, H2, over 1 mole of H2. These will cancel, and then you'll get your answer there. So these problems you work the same. Now when we get to number 6, we're going the other way now. We're already out here. We're out the end. We're at 20, we got 11.3 liters as our given, and we want to find out how many moles. So since we're out here at the end of the triangle, if we're going to the middle of the MVP triangle, we're always going to divide by either, in this case, 22.4. So we're going to set up our given, because doing all this is just a series of conversions. We're going to, this time, now we've got liters in the top up here, so we're going to put liters, and this is of Cl2, chlorine gas. And we're looking for moles. Moles of chlorine gas. Important to put the units and the chemical on there. Don't get lazy and not do that. I will not give you points if you haven't done that. And then if you forgot what to put in here, well, you can look on the MVP triangle, and we're going to have, it's one, let's see, it's going to be 1 mole and then over 22.4 liters. So 1 mole of chlorine gas will take up 22.4 liters of chlorine gas. Make that a decimal point easy to see. Now, for the rest of these, you're just taking the given and dividing it by 22.4. Number 10 and 11. Now, these are, let's see, for number 10, it's starting at 10 grams. So, excuse me, at 100 grams. So, what you have to do is look at your MVP triangle. We're starting at grams, and we need you to go to liters. So this is the first of our multi-step. You're starting at grams right here. So you're going to have to first convert it to a mole by dividing by the molar mass. Then you're going to need to multiply it by 22.4. It's going to be 2 steps. The given over 1 times that fraction times that fraction. So we'll get that one set up. 100 grams of O2 over 1, that's our given. And then we need to, according to our MVP triangle, we need to divide by the molar mass of oxygen. Now you've got your paper, you can look up the molar mass of oxygen. We're going to say 1 mole of O2, because that's what we have to do on the MVP triangle. 1 mole, in this case it's O2 over the molar mass. And I'll let you look on your paper to find out for O2, it's going to be how many grams of O2. You've got that already on the first sheet we did, and it's just going to be multiplying oxygen's atomic weight by 2. So now that's going to let you cancel these out, and now at this point, now you're going to be at moles, and you need to figure out how many liters. So when you're at moles of O2, you're just going to multiply by 22.4. 22.4 liters. Now the gas is O2, is 1 mole of O2. That'll cancel with this. So once you plug in here your molar mass, now in your calculators, you're going to need to do, you can do it a couple of ways. You can do 100 times 22.4 equals, and then divide it by the molar mass. Your scientific calculators are pretty cool. You could do 100 divided by the molar mass, and then hit times 22.4. You can do it all in one step. But I do want you to get used to 100 times 22.4. Don't hit equals, hit divide, whatever the number is for the molar mass, and then you can hit equals. And you can do that all in one calculator action. All right, goodbye.